Oil palm tree or Elanus guniculae has been considered a prominent vegetable oil in the food industry. The sector played a big role for Malaysia and Indonesia as the main oil palm producer in Southeast Asia. Both countries identify this sector as the main commodity that contributes significantly for the country. Despite the enormous potential from oil palm product, plant disease infection in oil palm can limit the target for both countries. The basal steroid disease infection from Ganoderma cost loss up to 500 million USD in economic damage per year. Up to date, there is no solution in BSR disease assessment. Therefore, geodetector Ganoderma basal steroid disease alternative innovation in this research. And this is the real condition in oil palm plantation tree that has been affected with BSR disease infection through all the symptoms from T0 until T4. And this is the process of development geodetector for BSR disease. Through BSR disease symptom that can identify in oil palm plantations, and the ground census data and UAV multispectral data. And it also can be viewed through on-ground view and ground canopy view. And this is the data processing for geodetector BSR disease, started by input the UAV multispectral data into ArcGIS software, and this is the result. And right after that, we are going to input all the ground census data that have been collected before on ground, and the data consists from T0 until T3, which indicate T0 is in healthy and T3 is the highest infection. And so as we can see at this point, 2, 3, 4, T3 level of 3 identified. So for the next step, we are going to conduct training sample from ground view specific for the front leaf, as we can see for this sample. So to make it even better, we are going to focus for the ground canopy by removing unnecessary feature on the image. Right after that, we are going to perform spatial analysis tool with specific segmentation and classifications. And we can choose for train random tree classifier, or also known as random forest in research. So we're going to choose input raster through ground canopy and input training sample from training sample that we have conducted before. And we can save our final classification of machine learning through our desired folder. And right after that, we just click OK. And this is the result for the classification machine learning of random forest and have been performed. And we can check for the accuracy assessment by establish the random accuracy point, which is in 203 of random point that have been developed by the system. And this is the result for the classification using 3 different methods of the machine learning.